Hi, this is Stephen Hu, and for my advanced talk presentation, I chose to talk about Astronet. It's a AI machine learning program that detects exoplanets. Here's my 5 tuple, and over the course of the slides, I'll go over them more in depth. So the AI theory is deep learning. It's a form of machine learning that mimics the human brain to solve problems. So where the human brain has neurons, where each neuron solves a small part of the problem that we're going through, neural networks mimic those, but instead of neurons, they are nodes. And so in each node solves a small part of the problem in the same way the human brain does. So a neural network is composed of an input, a hidden, an output layer, and the input and output layer exactly sound what they sound like. The input takes the input, and the output layer takes the output. But the hidden is where the calculations are done essentially. So for AI that detects human faces, one part of the neural network would determine if it's a human nose or not. Another would determine if it's a human eyes or not, etc. The AI platform used with TensorFlow. It's a pretty well-known AI library made by Google. The name comes from being able to build data flow graphs and structures called tensors. It's used for many applications like self-driving cars, and also for more subtle things like on one farm they use TensorFlow to sort cucumbers based on the textures. So a little background knowledge: exoplanets are planets that exist outside of the solar system. The interest due to them is the potential for extraterrestrial life. They're usually not found through direct imaging, but they're found through more subtle methods, which I'll talk about more in the slides. So how Astronet works is it takes data from the Kepler Space Telescope and it uses and trains a neural network to identify potential candidates for them. And I got all the data. I got all the code from their GitHub, which is publicly available. They made it open source for anyone to see. So how it works is it detects light curves. So as a planet passes in front of a star you're observing, the brightness will go down over time for a certain period of time, and the machine learning uses that to determine whether it could potentially be a planet, because light curves can be caused by multiple different things, such as a star passing or another star passing orbited through it, or it can even be the brightness itself of the star just fluctuates over time. This is the code for the light curve for Kepler 90. It's a distant star, and when you put it in for TensorFlow, it should generate this. As you can see, the brightness fluctuates just a little naturally over time, but here it's where it really dips, and so the AI would see that could potentially be a light curve, or it'd see that that's a light curve, and it could determine that it might be a planet. So first, you run this code to train the program, and then use the top part. You type in the top part. You can use all this. You can type this all in terminal, and if you do everything correctly, this is the output that you'll get. And so the main thing you want to look at is the accuracy. So for here, with the data you put in of Kepler 90, you'll see that there was a 0.9625159, which basically is saying there's a 96.25% chance that what you saw was an exoplanet. And you wouldn't stop there. You'd consult with astronomers, you'd run more tests, etc. But this is a really neat way of finding potential candidates for exoplanets. And that's it. I hope you enjoyed my presentation. Thank you.